right. Well, thank you a lot for attending here, and thank you for sticking along until the end, almost the end of the talks. Don't worry, I'll try to not make it too complicated, and yeah. But nonetheless, we'll be talking about reputation here. We'll be talking about building trust in a decentralized economy. Why? Well, if we take a look at our normal economy right now, well, it's based on trust. Possibly too much trust, and that's why blockchain's decentralized. But we still need trust, right? The bank trusts you that you're going to pay back the loan once, and that's why they give you the loan. So trust is an important tool for us to have efficiency in our economy. But we don't have that in blockchains, right? Or at least not yet. Like, we don't trust each other. We don't know who is a real person, who is not. We don't know anything about the trustworthiness or reputation of people, right? And yeah, that doesn't work quite well. So the more traditional way that you can seed that trust is by doing KYC, know your customer verification, so verifying your users that they are legit. However, that's obviously the total black sheep in blockchains because, well, it's totally non-private, it's totally centralized, and it also takes a lot of time. So that's why, hence, nobody uses it, understandably so. Well, what we do at Outed is basically this, but native for the Web3. So that's fully privacy preserving, using zero knowledge cryptography, fully decentralized, and also happening instantaneously. All right. So essentially what we're trying to do is we're trying to nail this sweet spot between, well, privacy, decentralization, and verifiability. So like how much we can prove about the user versus how much the user doesn't have to reveal to anyone else. Okay. And we believe we're one of the first players in the industry to be able to get more verifiability while still not compromising privacy. And something I should have mentioned at the start is that we just got a grant from Aurora, so we're bidding on Aurora. But yeah, and we would love to start operating and talking with the DeFi apps in the air to see what kind of verification they need. So can we put the video, please? So before I say how does that work, I'll just show you the demo. So we've got a mobile app, and this mobile app, you're going to take out your passport or your ID card. Most likely, this ID card will have an NFC chip inside it. So, so our mobile app, what it's going to do is it's just going to scan that ID document as an NFC card. There you go. So this is our mobile app. It is reading the ID document right now using NFC. In a couple seconds, it's going to show you your personal information, like your photo and everything else, whatever it could read from the ID document, and more things. Now, the next step is to actually generate a zero-knowledge proof that this document is valid, that you're over 18, that you're not on a sanctions list, or whatever else you need to prove about yourself in order to be able to use some sort of DApp, DeFi app, or service, or whatever. So let's say we're going to start generating the zero-knowledge proof. That usually takes some time, a few minutes. We're working on making it better, no worries. Once it's done, this is how a proof looks like. It's boring, I know, but it doesn't reveal your private information. That's the most important thing. So you can take this proof, you can send it to Uniswap, you can send it to whatever you want, whatever accepts this kind of proof. They can verify that you've been KYC'd, but it doesn't share, but nobody received your private information in the end. And that's basically what we're doing in a nutshell. So the next few slides will be all about me trying to explain how does it work if you guys are curious. And yeah, to just unpick the cryptography behind this in a human readable language. Okay. So first, let's talk about zero knowledge proofs. And I'll try to make it quite simple as to what these things are and how do they look like. How do they allow you to prove something without showing it to anyone else? So let's say we got a very, very simple function that takes 3 numbers. And let's say that the task for me is to prove to you that I know that A times B equals C. And you know what's C, like C is public, but you don't know what's A and B. And I need to prove to you that I know that A times B equals C, but without showing you the actual A times B, right? So zero-knowledge proofs allow you to do this. So let's say we've got this function. I can say that A is private, B is private, C is public. And I can take this, I can put it into a magic black box called the zero-knowledge prover, and it's going to output a proof that looks like exactly what I showed you a couple moments ago. You send that proof to whoever wants to verify it, and now they know for sure that I know some A times B equals C. Okay? And that's pretty cool. So let's take this concept, let's take it a step further, and let's apply some more cryptographic primitives to it. So let's say that now I'm trying to prove something more complicated. Let's say I know Jack. Jack is some blockchain user or whatever. So they've got a public key, they've got a private key, Jack. And I want to prove to you that I know a piece of information which has a signature by Jack. Okay? But I don't want to show you that information, and I don't want to show you that signature. So what I'm going to do is, so I'm going to do this. So this is the data that I don't want to show you. This is the signature that I don't want to show you, and this is the public key of Jack, which you already know. And I can generate a zero knowledge proof that, well, that the data I have is actually signed by Jack without showing it to you. And yeah, it just works. And if we just take this a slightly step forward, that's basically how audit works in a nutshell. So let's say you've got a passport. This is data like your name, the social security number, everything else. Then you got a signature over that passport by the issuing country, let's say the US. And then you got a public key of the US. And so I can prove to you that I've got a passport which is legit, which is properly signed, which came from America, without showing you anything about it. So that's the base fundamental idea of how audit works. How does it, like, how do we get this signature document thing, whatever? Well, there's actually a pretty big international standards of passports and identity documents which have an NFC chip. So you can actually digitally read your passport. Most of you guys, nearly all of you, should have this feature where you can read your passport and it's going to have like your passport information, but well, in a digital format. But it's also going to include a signature from the country which issued your passport, let's say US or whatever. And this is the key that actually allows us to generate proofs and do the whole privacy thing here. And it's because we can make a ZK proof that you have a legit passport, and that you're over 18, that your name is not on terrorist blacklist, and all kinds of other, let's say, questions, without showing you anything about it. And yeah, and you can't really cheat. So let's just like zoom out a bit. How does this proof actually fit within the whole audit model here? Well, let's say we got Bob here. Bob wants to use any swap or some swap or whatever, and some swap wants Bob to prove that they're over 18. Okay, so Bob uses our app, and they scan their passport, and our app generates a very clever proof that proves that Bob is over 18, and other things, whatever the app wants. And then this proof gets sent to our smart contract on chain. It gets verified, and then the SumSwap, the app, gets notified that, hey, Jack now can use your app. So Jack now can use the app. And that's great. However, there's still a bigger question to answer here because, well, you can verify people, sure, zero knowledge, nobody knows anyone, but what if Bob ends up doing something very illegal? Like, you still probably need to know who they are so that you can, put them to justice, right? This is kind of the point of KYC. You can do that by having a centralized database, and you have this centralized KYC company which knows everyone, and you don't really know what kind of shady deals they do behind them and how they share your personal data. Or you can do it without it. So how does it work? Well, same thing, except passport comes through, and we actually take the user's personal data, like the national identifier, like social security number or whatever, and we split it into multiple different pieces, like separate pieces of information. And we send them to a network of multi-party computation nodes. Now, I'm not going to explain how MPC works in detail, but what you need to know is that every one of these nodes knows a piece of the user data, but they all need to come together in order to learn, in order to actually combine and actually read the user data. And so, just like within a blockchain, these are nodes, so you can give them a protocol to execute. And the protocol could be, you guys can't share the data to anyone, except if the police comes and asks for it, for example. So we can say this, we can say even more complicated rules, but the whole point is that you know exactly how your personal data is stored, and there is a very clear decentralized protocol on what needs to happen in order for your data to be read and accessed. For example, like let's say the police needs to have a warrant or something very serious, so that you know that nobody else can steal your data in the background, or the KYC company can't do some deals or learn your address or anything else, unless, again, something with it all breaks down and they need to see who you are. But that's basically it. And now, if you take this just a step further, okay, and so now users, let's say, unique national identifiers is stored in the multi-party computation thing. Well, you can actually use this to generate a permanent global decentralized identifier for that user. So no matter which blockchain they use, like no matter like if they verify themselves using Audit on like Avalanche, on Polygon, on Aurora, or whatever, they could, if they go through this process, they always get exactly the same DID, exactly the same identifier. And that's pretty cool if you want to have more reliable reputation models, or like scoring or being able to prove that you did multiple accounts in multiple different blockchains. So yeah, I think this is the first, or even one of the first implementations of decentralized identifiers, which is fully Sybil resilient, which means Sybil resilient and blockchain agnostic, which means no matter which blockchain you use, you always have the same identity. So imagine, let's say, Uniswap or some dApp has DAOs, has token holders on multiple different blockchains, and they need to do a governance vote. And also imagine that they want to do a governance vote in a one vote, one human type democratic setting. So they can't really do it right now because, well, you don't really know who's a unique human. And if I prove that I'm a unique human on Ethereum, maybe I can also prove that I'm a different unique human on Avalanche, right? With this, you can't do it. So it unlocks quite a few different possibilities. So we're still exploring all the different use cases that this can have, in addition to normal KYC and all the regulatory ways in which this could be used. Decentralized project could also want to use this for, on their own initiative if they want to do age verification. They're selling, for example, adult content. If they want to verify or trust their borrowers more to give them, let's say, better loan terms, or if they want to verify that if you're making an institutional pool, maybe you want to verify that something about the institutional investors in that pool, and democratic voting, citizenship, things like that. Or if you have an offending user, you want to blacklist them forever. Like if you really want to make sure they can't access your app again, or for a limited number of time because they did something bad and you don't want them to come back again, you can effectively blacklist them so that they can't make a second account. Another cool thing you can actually do is, if you want to collect user insights, you can do that in a way here too. For example, you can ask your users to prove that their age falls within a few boxes. Let's say, less than 18, 18 to 25, 25 to 40, whatever. And this way, users don't have to review their exact age, but you still get to collect the insights. So that's cool too. So with that said, there's still a few things we need to work out. Obviously, it's not all sunshine and rainbows. And in particular, the most obvious way that you can cheat the system is if you steal someone else's passport and then you verify yourself. Because right now we don't verify your face and anything like this because, well, this will require a centralized KYC company to do that, and that's kind of what we're trying to replace here. So there are a few other clever ideas to use extra data, extra source of information to make sure that you actually own the passport. For example, you could prove that you can log into a government tax account or some sort of online government service that has your name on it. And there's a way to do that while still revealing your while still protecting your privacy, and you don't show your name to anyone, et cetera, et cetera. But you can prove that you really are the person to a good extent. Another thing is that we only work with NFC-enabled identity documents, which is quite a few people, but not everyone. So yeah, for example, not everyone carries their passport with them, and your driver's license probably doesn't have an NFC chip inside it. So it probably won't work. So we're working on how to actually increase adoption and be able to support non-NFC IDs, which is actually a pretty decent technical challenge because they don't have signatures. So ZK proofs kind of don't work here. So yeah. And otherwise, yeah, the proof right now takes about 5 minutes. Could do it faster. That's it. So we recently got a grant from Aurora, but we've been building this for the past 5 months. We got a white paper. We have a team of 2 developers, in addition to Anna, my co-founder over there, and Alexi, our advisor over here, conveniently placed in the first row. And yeah, so we'll be publishing the test version ready in about 3 months. And for this, yeah, so that's me, Anna, and Alexi. Yeah. So for this, we really want to know if you guys are curious to test it out. We're setting up all the initial pilots right now. So if you want to test out our KYC project, if you want to see if you want to use this for your users, given the circumstances, definitely let us know. This is our email, or you can scan it. Or we also have a Telegram community, so definitely connect. And yeah, if you could. No, everything's good. So yeah, so now we're open to questions. If you guys can keep that slide so people can scan the code. So then otherwise, yeah, if you got any questions, I'm open for it.